So we are discussing software engineering questions, descriptive type questions. So what are the assumptions of execution time component model? And compare the execution time component for basic model and the logarithmic Poisson model. Assumptions of execution time component model. The execution time component is based on these assumptions. First is the test represent the environment in which the program will be carried or will be used. All failures will be observed and the failure intervals are independent of each other. The hazard rate is a constant that changes at each fault correction. The failure rate is proportional to the expected value of the number of faults remaining, and the fault correction occurrence rate is proportional to the failure occurrence rate, and both the rates are with respect to the execution time. So these two models, basic execution time model and the logarithmic Poisson execution time model, have failure intensity functions that differ as functions of execution time. But the difference between them is best defined in terms of the slope or decrement per failure experienced. The decrement in the failure intensity function remains constant for the basic model, while the decrement per failure decreases exponentially, as we can see that as the defects or the failures are removed, or the cause of failures are removed. Basic model, it will remain constant, but for the other case, logarithmic Poisson, it will decrease exponentially. Describe the various types of restructuring techniques. How does restructuring help in maintaining a program? Software restructuring modifies source code or data and to an effort to make it amenable to future changes. So in general, the restructuring does not modify the overall program architecture. It just tends to focus on the design details of individual modules and or the local data structure which are defined within the module, not the structure. Complete design or architecture will be affected. So there are different types of restructuring technique. First is your code restructuring. That means it is performed to yield a design that produces the same function but with certain higher quality than the original program. So in general, this code restructuring technique model program logic using some Boolean algebra and then apply a series of transformation rule. This transformation rule that yield produces the restructuring logic. The objective is to take a spaghetti ball code and derive a procedural design that conforms to the structured programming philosophy. Then we have data restructuring. So before data restructuring begins, a reverse engineering activity called the analysis of source code must be conducted. The intent is to extract data items and objects, also to get the information on data flow, and also to understand the existing data structure that we have implemented. So this activity is also termed as data analysis. And once it is complete, the data design starts. Another form of redesign, which is the data rationalization, which is ensuring that all data naming conventions conform to our local standards and that aliases they are eliminated as data flow through the system. So the restructuring helps in maintaining a program in certain ways. First of all, programs will have higher quality, they will have better documentation, the complexity will be reduced, the conformance to the modern software engineering practices and standards will be there. The frustration among software engineers who must work on the program may be reduced just by thereby improving their productivity and making them learn things easier in the fast manner. The efforts required performing maintenance activities is quite reduced and the software is easier to test and debug. Describe the various steps of the reuse-oriented model. This ROD or reuse-oriented model is a method of software development in which a program is redefined by producing a sequence of prototypes called models. So each of which is automatically derived from the preceding one according to a sequence of defined rules. This reuse-oriented model can reduce the overall cost of the software development compared with more tedious manual methods. So it will save time because each phase of the process builds on the previous phase that has already been defined. And when actually carried out, this ROD can minimize the likelihood of any errors or bugs and making their way to the final product. The reuse-oriented model is not always practical in its new form because a full repertoire of reusable components may not be available. And in these cases, some new program components must be designed. If not thoughtfully done, ROD, result-oriented model, can lead to compromises in perceived requirements, resulting in a product that does not fully meet the needs of its intended users. What is ripple effect? What do you mean when you say ripple effect? So how does it affect the stability of a program? Ripple effect, like this. The ripple effect is a term used to determine a situation where, like the ever expanding ripple across water, when an object is dropped into it, an effect from an initial state can be followed outward incrementally. The examples can be found in economics, where an individual reduction in spending reduces the incomes of the others and their ability to spend. So in sociology, it can be observed how social interaction can affect situations directly related to the initial interaction, and also in the charitable activities where information can be disseminated and passed from community to community to broaden its impact. But what about software? The effect of modification may not be local to the modification, but may also affect other parts and portion of the program. So this is a ripple effect from the location of the modification of the other part of the program that are affected by the modification. So one aspect of the ripple effect concerns the performance of the program. So the primary attribute affecting the ripple effect as a consequence of a program modification is the stability of the program. So program stability is defined as the resistance to the amplification of changes in the program or the propagation in a ripple-like manner. List 4 reasons why it is difficult to improve the software process. These reasons which we are going to discuss are, they are much related to the process improvement areas, paradigm and technologies or the thoughts. So first of all, the lack of knowledge. Many software developers are not aware of the best practices in the program. They are not aware of ISO, they are not aware of CMMIs or Six Sigmas. So in fact, best practices available in literature are not being used, they are not widespread in software development. Not enough time. There is always shortage of time because upper management are always demanding more software of higher quality in minimal possible time. And realistic schedules sometimes leave insufficient time to do the essential project work. Then the wrong motivations, that is the process improvement initiatives, are taken for wrong reasons, like sometimes contractor is demanding achievement of CMM, or sometimes senior management is directing the organization to achieve CMM without a clear explanation why improvement was needed and its benefit. Insufficient commitments. That means the software improvement fails due to the lack of true commitment. Management sets no expectation for the development community regarding process improvement. Discuss the various strategies of design, software design. Which design strategy is most popular and practical? So the most commonly used software design strategy, which involves decomposing the design into functional components with the system state information held in the shared area. So we have two basic strategies. First is the functional design, the other is the object-oriented design. So what is functional design? The system is designed from a functional viewpoint, starting from a high-level view and progressively refining it into a more detailed design. So the system state is centralized and shared between the function operating on that state. What about object-oriented design? The system is viewed as a collection of objects, obj1 and likewise to obj(n). So system is viewed as a collection of objects rather than as functions. So the object-oriented design is based on the idea of information hiding. In an object-oriented design, the system state is decentralized, and each object messages is own state information. Structured analysis, structured design. What is the difference? The aim of structured analysis is to transform the textual description of the problem or the requirements into a graphic model. So during structured analysis, the functional decomposition of the system takes place. That is, each system that the system performs is analyzed and hierarchically decomposed into more detailed functions. While in the structured design, all the components identified during structured analysis, they are mapped to the module structure. So these module structures are also called as the software architecture for a given problem, and it can be directly implemented using a conventional programming languages. The aim of structured analysis is to capture the detailed structure of the system as perceived by the user, whereas the purpose of structured design is to define the structure of the solution that is suitable for implementing in most of the programming languages. Explain information flow index, span and average span size of a program, and function parts. Information flow index, information flow matrix. These are applied to the component of a system design. For any component, say A, we can define three measures. fan in, fan out. Okay, and this fan in is simply a count of the number of other components that can all or pass control to component A. Fan out means these are the number of components that are called by component A. And using the following formula, we can derive this. We can call this, measure the information flow index, this one, information flow index of A, which is abbreviated as IFA. That is fan in A into fan out A square. Span, an average span size of a program. So span size indicates the number of statements that pass between consecutive uses of a variable, span size. Let us give an example. Let me tell you again. A span size indicates the number of statements that pass between successive use of variable. For example, we have a sample code here. Variable x has 4 spans, 10, 12, 7 and 6. While y, what about y? Y has 2 spans only, that is 23 and 14. So this shows that x is being used more than y. X is used 4 times, y is used twice only. So average span size will be summation of span size of a variable in a program divided by the number of span. For example, the average span size of variable x in the above, in this is 10 plus 12 plus 7 plus 6 divided by how many times? 4. What about 2? 23 plus 14 divided by 2. This is average span size. Function points. Function point measures the, first of all, let me tell you, function point is like measuring. Like you measure distance in kilometer or meter. Similarly, in computer science or in softwares, function point does the same. So function point measures the functionality from the user point of view. That is on the basis of what the user requests and receives in return. Request and receive in return. It deals with the functionality being delivered and not with the line of codes or source modules or files. So what is the functionality which is delivered? This is the main aspect of your function points. So measuring size in this way has the advantage that the size measure is independent of the technology which is used to deliver the function. So what are the importance of the function point? This is independent of the language tool or methodology used for implementation. They can be estimated from requirement specification or design specification, and they are directly linked to the statement of request. Explain the development phases of the detailed COCOMO model. Development phases of the detailed COCOMO model. So a software development is carried out in 4 successive phases, which are like this. So we are talking about the development phases of the detailed COCOMO model. So let us see, these are 2 others. So we'll be talking about all these 4. Okay, plan requirements. This is the first phase of the development cycle. The requirement is analyzed and the product plan is set up and full product specification is generated. So this phase consumes 6% to 8% of the effort, that is 10% to 40% of the development time. Product design. The second phase of COCOMO development time is concerned with the determination of the product architecture and the specification of the subsystem. So this requires 16 to 18% of the normal effort, that is 19 to 38% of the development time. So 10% of this time, around say 30% roundabout of this time. And programming. This is the third phase and the design and which is implemented to the programming. So this is the third phase, and we have detailed phase and code or unit phase here. So it requires 48 to 60% of the effort, that is 24 to 64% if you combine the design, high-level design and programming. Integration testing, this phase of COCOMO occurs before delivery. So this mainly consists of putting the tested parts together and then testing the final product. This requires 60% to 34% of normal effort, around 80% to 34% of the development time. Then we have maintenance phase also, that also takes a lot of time. Why does the software design improve when we use object-oriented concepts? The software design improves when we use object-oriented concepts because object-oriented works at high level of abstraction. The development can proceed at the object level and we ignore the rest of the system for as long as necessary. The data on which the system is based tend to be more stable than the functionality it supports. The object-oriented programming encourages and supports good programming techniques and design and programming, object-oriented programming design and programming promote the code reviews also. Describe the system testing. What is a system testing? System testing are designed to validate a fully developed system with a view to assuring that it meets all the requirements. So there are various types of system testing. Actually, acceptance testing, some books say some other thing, some books say another thing. we'll try to make a distinction between all these. System testing is validating the system as a whole. That is fully functional, fully developed system. Verifying and validating, that is validating actually, not verifying. Verification has already been done. So validation of fully developed system. Alpha testing and beta testing, they are part of acceptance testing. So acceptance testing, it is performed by the customer to determine whether or not to accept the delivery of the system. So if alpha testing in terms of acceptance testing is done, then this refers to the system testing that is carried out by the testing within the organization. Beta testing is the system testing performed by the selected group of friendly customers. Define graph matrix and connection matrix. Graph matrix and connection matrix. So graph matrix is a square matrix whose size, that is number of rows and columns. Number of rows and columns is equal to the number of nodes in the flow graph. Each row and column correspond to the identified node, and the matrix entries correspond to the connection between the nodes, whether they are connected or not. Connection matrix means in a connection matrix, each letter has been replaced with, say, 1 indicating that a connection exists. Zeros has been excluded from the clarity. So these, there are a few more questions on software engineering. We'll be taking more. Thank you so much.